this is where we had already left off. And I did also fix it so I can now see what I'm talking about inside the document, you know, just in case. And that, I don't know why that came up. That's not good, but that's okay, that bar. We were talking about tracing and going to each top of each bin. And when I say top of each bin, it's kind of like I'm on top of this piece or on top of this piece. And it tells you how many there are. If I just look over here, it tells me everything I want to know about each of those intervals. The last paragraph was that if you decided to use 3 bins instead, and there's a mathematical way to get what the interval would have to be by hand. In other words, if you know you want only 3 bins, you could take the max minus the min, divide it by 3, round that up to a number, and then you can start with your smallest and do that window and so forth. And so if we need to do that by hand later, we'll try that. Maybe for our, we don't have a whole lot of data for pulse rate, so we'll do it by hand first. In a minute, we're going to need to do that. Okay, so any questions that we had that day? We're good? So if we move on, we're now being recorded. So the last time we met, we created the histogram on the NFL data. We also collected our pulse rate, your sets over there. We probably will be using it today. All right. And did everybody, even if you did have your calculator in class the other day, you were still supposed to get that histogram in your calculator? Probably still is there. So I'm going to start off, again, we're still in descriptive statistics. And got to get on the right page here. Next page. He says, since we'll be using this data several times, the NFL data, it does come up in a couple other problems. We don't want to, it took us a while to key it in. So you don't want to have to key it in every time. So he tells you a secret if you want to put it somewhere else. So what we're going to do is, up in here, we're going to, does it just record when I move? Yeah, it's probably better when it just moves. I don't know why it makes that line. Since we'll be using the same data, the directions here, oh, okay, something else happened here that prevent me from, okay, that's off, all right. Trying to move my page and it's not letting me. It's not what you want to record. Oh, I know why. It helps to press the right button. We're going to go back into your data, you still have, with stat and edit. And what we're going to do is we're going to move our cursor to the very top of the list of data. And you'll notice it says L1. But what we're going to do is we're going to go over to L3, and it's blank. In L3, we will press the Enter key, and it's going to ask us to, what do you want to put in L3? And we're going to tell it to put L1 in L3 to save later. Now, here's the bad part about the video. I put this iPad down, and in order to do the video, I've got to bring up the computer on top of this. So this is what's being recorded. So the person's going to be staring at this while we're on our calculator. So let me bring up you get your calculator out. And I'm going to get my calculator out. Okay. Actually, I'll unzoom it for now. So there's the calculator that is not going to be shown by the video. So they're just going to hear us. So my data is there. And if you hit Stat, Edit, stat, I'll do it from scratch. Stat, number 1 is edit, and that's what you already put in. And I can move over to any column of data that I want. And notice when I go up, it actually tells me all the data that's in L1. So he wants us to copy this into L3 because, you know, personally, if I want to use it in the future, I don't want to lose it. I probably even go farther over in the L's because the odds of you needing 7 lists of data at one time is rare. But 2 or 3, it happens a lot. But right now, I'm going to follow his directions. I want to paste all of L1 into L3 to store it because we're going to erase L1 and we're going to be putting in our data for our heart rate. So to paste that, the directions said, at the top, press the enter key. And at the bottom, he's asking you, well, what do you want L3 to be? And it's what's nice is you can tell it to be, you can multiply by list 1, you can take list 1 and take away 3, and that takes away 3 from every term, and then it pastes all those numbers. It's really, really nice. You can do a lot of things with this L1 and put it in somewhere else. But I'm just going to say, I want to paste L1. Now, here above the 1, you'll see in blue is the L1. So it's second, number 1, it pastes the L1 here. L3 will be equal to L1. And when I hit enter, L3 now is pasted for later. Now I want to save it, I don't want to erase it, or I want to use it later. Maybe I push it farther over, just depends. Now I want to clear L1 because I'm going to use it. So I go back to the top of L1. Be careful. There's 2 things you could do. You could hit clear, or you could hit delete. Do not hit delete. If you hit delete, it does go away. But so does L1. The whole column goes away. And you'll keep saying, how do I get L1? Where did it go? There is a way to bring it back, but it's really a pain. So hit clear and hit enter. And L1 title is still there, but everything is gone. All right? So let's see if this could come back up. Okay, I brought it back up. Oh, wow, you know what? I didn't realize if I played my cards right, I could use the calculator while this was still up. Look at that. But then it's kind of small, but you have it on your paper. So if there's any issues, do let me know. And this I don't really like. So I can't do it from there. Maybe it's this. Nope, that didn't help. That didn't help. Made it worse. I don't know. I'm not really sure why that came up. And there's no close. Anybody see anything else? Say it again. You see the word close? The blank side? Yeah. Like over here? Yeah. Yeah. Yeah, it doesn't seem to do it. I don't know. Interesting. Anyway, oh wait, maybe I go here. Oh wait, now it went off. Okay, I pressed the hand. All right. So this first line was storing L1 into L3 for later use. And now example 2. We just did example 1 was the NFL data. The collecting the pulse data was just an activity to collect data. Now go back to the first page and enter the data for your pulses you collected. So let's practice with the calculator first. We are going to enter the data from our pulse rate, our class, into L1. And we're going to, you know how fast it was to do the histogram with the calculator, was really, really fast. So we can actually all do it together. I'm already in L1. I think I can work with this. If somebody wants to read out the values, it's faster for all of us to get it in our calculator if somebody tells us what to type. So who's my volunteer? All right, Mr. Mohammed, real loud.
69.
69, and, oh, yeah, hit enter.
61.
61,
86.
86,
58.
58,
70.
70,
94.
94,
86.
86,
65.
65,
83.
83,
Yes, sir. 68.
68,
79.
what was that again?
79.
79,
71.
71,
88.
88,
97.
97,
And last but not least, 75.
last but not least what?
75.
75, and that tells me that's our 15th, oh, then that means we had 15 people because somebody was not sitting here or something? Oh,
This month.
okay,
You left.
he left, Christian,
Yes.
and,
Mallory.
but Mallory was here.
No,
No,
Mallory
Mallory
is
was
here,
absent.
but not today.
But Mallory was here that day,
Yeah.
okay, so that's fine. All right, so I hit enter on that. Review with me, what do we do to see this histogram without having to do any thinking? Does everybody remember the steps?
Oh, just that on.
It was stat plot, that's right, stat plot. Second, y equals, turn it on by hitting enter, making sure it's on. Of course it's on because it was still on from the other data. And make sure histogram is highlighted. That's the third icon over from the word type. Make sure I'm looking at list 1. Right now I could put list 3 here. I have data in list 3. You'll get the same picture as we did the other day. And so it looks good. So what do I do from here? I'm ready to see it.
Graph.
Okay, graph. Did it, oh wait, that's weird graph. What did I not do? I've got to tell it to zoom the way I want to see it. So zoom stat says, calculator, Mr. TI, I call him Mr. T. Please give me the best graphic you think you can do with this data. So I do zoom. Zoom is which number at the top of your row? Third one. Zoom number 9. And okay, look at that. Your data is also skewed to the right, which implies we have, we're dying. Not really, because, well, if skewed to the right actually meant the right tail is at the higher values. And it's a tail, it's smaller. So there's not that many people that's in the right side. Most of you are in this bulk, and that's okay. So that, and let's see, if this was a homework assignment, you would have to label your title, you'd have to label the axis. This axis again would be frequency. This axis would be pulse rate. That's right. So we need to put this on the paper. You have a grid there. So I'll help you do that in a second. But before I do that, hit the word trace, which is your 4th top button. So I can at least realize, oh, okay, they divided into 1, 2, 3, 4, 5, 6 bins. That was his choice. He could have done 7, but then it would have spread it out. He could have done 4, but then it would have compressed it. So the calculator, Mr. T, knows best, says that the 6 was an optimal look. And so the first bin, we've got 3. You might want to write that down or make that note somewhere, because we're going to put this on our paper. And the interval went from 58, and the next interval starts at 65.8. I need someone to do the math. What is 65.8 minus 58? Are you stuck on something?
Yeah.
Did you hit zoom number 9?
Yes.
Yeah, yours is different, are you sure, do you use the same data?
Use up quickly.
Did you plug in the data wrong? Just check the data, let's go stat, edit. Did anybody else get this picture?
Yes, sir, I did.
Okay, yeah, double check the data that, well, we're getting the data from up there. That, the data came from our class. It was these numbers here. Oh, no, yeah, 3A stats. It was 69, 61. Is that the data you're using? Okay, try it out. So anyway,
7.8, sir.
say it again.
7.8.
Thank you. So 7.8 is every interval. So you might want to take notes here really fast to realize that the first one had 3, and it started at, the min was 58. He added how much, did you say, sir?
7.8.
7.8, and got to the next bin of, well, you don't know yet until we hit, well, we know it goes to 65.8. That's where the next bin's going to start, because the right side of the bin counts for this bin, not the bin on the left. So in order to get the next bin, just for kicks, what is 65.8 plus 7.8? Say it again. 65.8 plus 7.8, I think it's going to be 73.6. Is that right? So the next one's at 73.6. And the easy way is just to hit the plus, the arrow to go over and see. Oh, yeah, there it is, 73.6. The second bin has 4. So the second bin has 4. And the next bin, I'm going to hit the button, 81.4, and there's 2 of them. So it goes to 81.4, and there's 2. And then the next bin, I'm just going to go to the next2. This is for my scratch paper. Next row, 89.2, and there's 4. So 89.2, and there's 4. And the next one is, hit the right arrow button, 97, and there's only 1. And there's only 1 up there. And I know I'm adding 7.8, so I have a feeling it's going to be pretty easy. It'll be 104.8, so I'm going to show you. Arrow over, 104.8, and there's 1. 104.8, and there's 1. So if I'm happy with this histogram, let me go back to my paper. There it is. Back to my paper. Get my pen out of here. And we're going to try to draw this here. So I am going to try to draw it in this grid here. My scale, my vertical, that is keeping track of my frequency, goes from, let's see, the max. The max is 4. I have a 4, and I have 1s. So that's going to be really easy. 1, 2, 3, 4. There's 4, there's 1. The bin width starts at 58, so I will start here at 58. And how many bins do I have? 7, was it? So I'm going to take off, that's 1, 2, 3, 4, 5, 6, and 7. And I've already labeled all the numbers. So it's 65.8. Whoop, messed up. 65.8. What's the next one? 73.6. 81.4. Should have made it bigger. 89.2. 97. course, yours will look better than mine. And 104.8. Sounds like a radio station. All right, so my first frequency, according to the calculator, was 3. So I take the right side of this bin and I go up to 3. Whoop, make it straight. Go over 3. Didn't even put 3. Next one was 4. So I have to go up 4, go over 4. Next one was, I don't remember. How many was at 73.6? I don't think I marked it. Somebody take your calculator and do the left arrow key to get to the third bin. There was 2. So 2 would be here. And then at 81.4, there was 2 also. Are you sure? I don't think the third one was 3, 4, 2, and then 4 again. Oh, that's what happened. I put the 2 there. So that one's 4. So I'll go 4 for this next one. Then there was 1 and a 1. Is that right? Wait, I'm missing a bin still. Yes. Where at? Oh, here? Okay, so let me, I thought I was writing what I heard, so let me get rid of all of them. This is why I pay you guys the big bucks. And that way it'll make it easier for me to write it in. Okay, yeah, that's what's important. So give me the numbers again. It was 58 and then
65.8.
65.8. And then
73.6.
73.6 then.
81.4.
Good. And?
89.2.
And?
97. 104.8.
Oh, that was the last one? Oh, okay. And then I do want the right end point after that, because that gives me 1, 2, 3, 4, 5, 6, 7. What would this final number right here at the end be right here? You'd still add the 7.8. What's 104.8 plus 7.8? $104.8 plus 7.8, just to get the borderline here. Louder, please. 112.6. Okay. Are these bins? Are these bars okay? 3, 4, 2, 4. Are they wrong too?
No, they're right.
Okay. So what's the next bin then? How many was in starting at the 89? Was it 89.2? How many is in there? Only 1? Really?
Yes.
1, 2, 3, 4. Why do I only see, was I wrong on the 7 bins? Was there only 6 bins?
Yes.
Oh, I was wrong the whole time. I said that earlier, right? Don't be afraid to say I counted wrong. So I won't need this last one. Okay, 1. Whoop, I don't want that color. 1, and I don't need this at all. Okay. I want that erased. It's odd. Questions? So that was with the calculator. We need a title, as always. Gotta have our title. What'd be my title? I'm gonna go period 3A stats heart rate. Heart rates. It is the distribution of this sample. Questions? That's with the calculator. You still had to go back and had to do your tracing. If you choose to use just the default, what the calculator came up. But what I want to do now, I don't know if I can add a blank paper on this. I would really like to have a blank paper into this. Let me try it. Add a blank paper and see what we left off on here. Well, okay, I hinted to this stuff already. Shapes of distribution. A distribution is symmetric. See that right here? Symmetric if the right and left sides of the histogram are approximately mirror images. So if you look at the bottom here, without looking at the words, which 1, 2, 3, 4, 5 look more symmetrical? They actually gave it to you. You can cheat. But which one looks like a rectangle? Third one, right? So if I was a betting man, you know, I would pick that because it looks so much like a rectangle. And we've talked about the term skewed. The distribution is skewed right. Can somebody else finish that reading, please?
If the right side of the histogram extends further out than the left side.
Which of those pictures, without cheating, which is farther right? Exactly. You see this tail? Skewed to the right. Which one skewed left? The last one, yeah. The last one, you see that tail? Now, would you think that maybe the first one also looks like it could be skewed?
Yeah.
Yeah, but is that tail farther out than this tail? It's not really that farther out. This may be narrower, and that's exactly why they still call it symmetric. It's still symmetric. It's because it has, the tails are about the same on each side. Even a perfect normal curve. A perfect normal curve is symmetrical because it's got a mirror image. If you cut it down in half, you could fold it over. And this is the same picture as that picture. So this could be cut in half here, and it's almost the same. It's not perfectly symmetrical, but it's close enough for government work. It'll pass. How about this? If I cut this down, does it look symmetrical? Could you fold it over like a sandwich? Yeah, you could. But they also told you something here. What's this word here? Bimodal means two humps. This is actually, if I trace around it, I would call this more unimodal. Bimodal because there's two different peaks. This really merges into one peak if you really want to talk about it. This was symmetric, also uniform. I should really correct myself. Symmetric doesn't mean the rectangle. The uniform means rectangle. Symmetric just means it's the same mirror image if you cut it in half, that's what happens here. And this is skewed to the right, this is skewed to the left. Questions on that? That's just terminology. Stemplot. So, Stemplot, this is new for you. That didn't help because that's not the eraser. This is the eraser. A Stemplot, let me do the shading this time. Sometimes called stem and leaf. So we're going to make stem and leaf. And so your job is going to be, we got data here, and stem and leaf is good when there's boys and girls or cats and dogs or people from 1920 and people from 1921, and you want to compare the shape of both pieces of data. And this stem plot is already done for you. Take a look at it here. Thank goodness you're not having to do it. But if you look very closely, this data here, all the girls, this number here, these two numbers go together as we'll call that the girl data. That's a 93. I'm sorry, I lied. Let me do it again. That data is it goes left to right, 39. For a boy, there's also a 39 for a boy. And if you look up at the data, let's see, I think I could find them. They're there somewhere. 39, 39, somebody tell me where they are. Ah, here it is. Here's the boy data, 39 girl data. It's like looking for a needle in a haystack.
On the bottom,
Bottom, in the middle,
67.
39. So there's that one. That's how you read the data from a stem plot. This is called your stem right here. That's your stem. And the reason they call this stem and leaf, you could pretend it looks like here's the stem and here's your leaf coming out. The veins of the leaf, you see the veins of the leaf? Are these things here? Stem and leaf. Or we get lazy and say stem plot. Same thing. It just depends how fancy you want to be. And nobody's ever accused me of being too fancy. So I can list all the data if I truly wanted to, and I really don't, but I'll just list a couple. Look at here. I'm going to do the boys. That's a 42 and a 47 and a 48. The fives, 52, 50, what else? 53 and a 59. 62, 63, 65, 66, 67, 68. So if we didn't already have the picture and you were supposed to create the picture, you'd have to sort the data in order because you have to have them in order to know where they would go. And then you got to decide on how am I going to count my stems. Well, I'm going to count my tens place to be the stem, the tens place. So I do a 3, 4, 5, and you find out your min was a 39. I find out my max is a 98. See that 98 on the boys' side? So I would go from 3 to 9, and then I would fill in order as best as I can in order. Okay? And the girls the same way. I've got the 39. I got a 40. He didn't put it in order here. 44, 42, 48. See that data? 54, 57, 58. That one's okay. 54, 57, 58. It's not that it's wrong. It doesn't change anything about the picture. So to create it, you put your data in order. And you don't have to have girls. You could have done a stem and leaf on just one set of data. Which I bet you any money we're going to do a stem and leaf on your data. Okay? It could happen. By the way, the stem doesn't have to be single digit. If you know you got a lot of values that go up into hundreds, it could be a 1 0 for 110. 1 1, I mean 1 0 would go hundreds. 1 1 would stand for 110 if you go 0, 1, 2. You have that level. Okay. But this problem he had boys and girls. So you put them together because what we really like to do is compare the two sets of data. I have a feeling we're going to compare boys and girls with a stem plot. I just have a feeling. And if you look at the stem and leaf shape, I'm going to go a shape over here. And then I'm going to do the girls as well. And do they look much different? By the way, what was these for? These were, what was the results? What were we graphing here? It says, final exam to several classes and examine the grades by gender. So if I was really a betting man, I wouldn't see a whole lot different between the boys and the girls on this test. Except for More boys scored in the 90s than in the girls. But I'd have to count each of these up to see, well, let's look between 80 and 90, or let's go from just the 70s and above. Which class had more pass? So you could do that. What else could you do? You could look at the data. You know what? Shading doesn't erase. That is really odd. I didn't know that. I thought everything could erase. Live and learn? What does this do? Oh, I bet you this paints. Let me do this. No, it's not doing anything. Just look pretty, that's all. Back to erasing. Oh, there. Got it. How would I find the median of the boys' grade? How would I find the median of the boys' grades? Somebody real quick. Do I know how many there were? Did he tell us in the reading? Can you count them? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Two of those, that's 34. 34, so what's the median of 34? Well, 17 is half, right? 17 and 17. So I have to really use the 17th and the 18th value. So I start at the lowest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Here's the 18th. There it is. It's between what two scores?
72, 73.
Oh, you're so good. You didn't just say 2 and 3. Yeah, 72. What happened here? 72 and 73 is between it. So what's between those two? 72.5. You could say the median, big M, 72.5. So that's a good judge of center, median. Let's look at the girls. How many were there? I'll count from here now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, so 15 on one side, 15 on the other, and 1 in the middle gives you 31. That's the 16th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The winner is 75. So the median is higher. So you could probably say what? Who did better, boys or girls? Of course, as always, right? So that's a median. That's a median, big M, median. I could do the max. Who had the max? We already said that the guys did. The men, who had it? They tied the men. Both had 39. So there's a lot of things you can talk about by looking at this picture of a histogram. Do you see where I'm coming from? So let me go to the next page. Yeah. So what I want to do is I want to do it completely by hand now. Okay? So assuming, not that the calc test, the AP exam, nothing's ever all by hand. But, you know, we're better than that. So I'm going to still make my axis. But here's my mathematics. My max was, what was my maximum heart rate up there? How much?
94?
94?
No, 97, 97.
97. Okay, let me fix that. It's okay. If I can count to 7 and there's only 6, you can say that. What was our min? Who was our runner?
58.
58. So if I decide, I'm just thinking to myself, if I'm doing this for myself, I'm going to do the range, which was 97 minus 58, and that is how much? Don't all do it at once. How much? 39. And I'm going to ask myself, how many bins could I get out of 39? If I divide by 2, it's not enough. 4, that'd be almost 10 with each, but maybe 4 is not enough. So I could say 5. Let me do 5. Let me be different than the calculator. What if I say 5? And I pretend instead of 39, I'm looking at 40 because I can do the math in my head. 80 divided by 5 is, 40 divided by 5 is 8. So if I choose to do 40 divided by 5, that gives me 8. That would tell me that the widths are 8. So I will start you said my min was 58. I will put 58 there. 58. I don't have a problem. Oh, I don't want that to rotate, but it's going to rotate. 58. And add 8 to that. Somebody? 58 plus 8, 64. Don't make me do all the work. 64 plus 8 is? 72. 72 plus 8 is? 80. 80 plus 8 is?
88.
Tell me when to stop. 88 plus 8 is?
96.
96. What was my highest?
97.
Oh, my highest is 97? I thought I was doing 5 bins. 1, 2. What happened? Tell me what we're saying or thinking.
58 plus 8 is 66.
We're at.
Oh, that's true.
We're at.
The
64
first,
instead of
the first
64.
number
It was how much?
66, not 64.
Oh. And I did that. See, I told you don't make me do all the work. You make me do all the work, then obviously there could be an error there. How are you doing?
It's the only time I could get away.
No problem. I couldn't get away. It's one of the things.
I know, you're busy.
Ah, it's okay. I got it. Thank you very much. I appreciate it.
It's in the lounge.
Honestly, I don't know what.
All right. Yeah, if you rely on me to do all the math, you're gonna have a lot of errors. So somebody should have yelled at me a long time ago. So 60 what? 6.
That's 74,
Go on here. 66, 74, 82, 90, 98. Is that all I need? Yeah, because the highest was what? Yeah, so I knew 5 should have gotten it. So I knew I made a mistake somewhere in the mathematics, and I'm the one that did that because I was waiting for you guys, and you didn't answer me, and I said, oops, okay. So now I'll go back to my data up there, and I didn't sort it or not, but it's your job right now. Go, looking at our data, how many are between 58 and 64? How many? I heard somebody say 1.
No, it's 2.
It's 2? Okay. So I'll go,
58, 64, 61.
all right, so you say 2. Final answer, 2?
It's 66 on the board, so the 65 counts.
Oh, right.
There's a 55 up there?
there's 65 up there, but it should be
61 and 64.
Okay, so 2. So I'm going to go up to 2. How many are between 66 and 74?
You know, Mr. Cartwright, actually for the first one, it's 3 because there's 65.
Oh, there's a 65. I thought somebody counted that.
Yeah, I didn't see that. But Miranda pointed it out.
Okay, good job, Miranda. So we will go up to 3 then. 3. Well, it's 3. Then the next bin. 4?
Why me?
So final answer? 4. So 1, 2,
Okay.
1, 2, 3, 4.
Yeah, I see 4.
Next bin.
Two. Two.
2. Final answer?
Yes, sir.
Next one.
Okay, so that's 1, 2, 3.
I thought I was bad. Final answer by the majority? 4 again. So I go up to 4 again. Okay, we got one more bin. And, you know, by default, we had 15 up there. So it's 8, 9, 10, 11, 12, 13. There should only be 2. So double check.
Oh, I counted 97. This one.
2. Okay, so there it is by hand. Now, if you compare our picture with the original, it really doesn't look much different except for the computer had 2 of them at 1. But because I only had an interval of 8 and it had an interval of 7.8, it kind of fudged the boundary somewhere and we stole one from somewhere, messed it up. Actually, 2 bins changed. But the idea is still there. I actually kind of like this picture even a little better because in talking about what I mentioned before is if you were to do a curve about it, it doesn't look too skewed. Doesn't look too normal. It looks more, it looks closer to getting closer to symmetric. Symmetric would be like a rectangle. And it's almost a rectangular block. But, you know, with only 15 data items, it's hard to really get a great picture of our data. But I at least can tell you, let's see, if there was 15, the mean would have been the 8th number. Watch me. 3 plus 4 is 7. The 8th is in the 2. The median is in here. So I know your median. I could say the median heart rate of this class is between 74 and 82. Because I counted it by labeling that. And the mean's probably not far from it. But I'd have to actually average those up to C. I don't really see a big tail, so the tail would have pulled the mean. The mean and the median should be about the same unless there's some weird behavior happening, especially on the outside. When you have weird behavior out in here, then what tends to happen is it pulls the mean. But enough of that. Okay, so let's see. I like this because I can actually put that little bit up in the way and say, quit bothering me now. And I can do another problem. That's kind of cool, I think. Nothing else I ever have. My smartboard won't let me do that. Let me go back to that page where we... Next page. That's my scrap paper. All right. 4. Following is the total number of medals in each country won in the 2004 Summer Olympics. Create a Stemplot for the data. So this is not a back-to-back Stemplot. The boys and girls was a back-to-back. This is just one Stemplot, and he kind of did you a favor. He put 0, 1, 2, 3, 4, 5, all the way to 10. Which means if I put a 1 here, that would be 101. If I put a 4 here, that would be a... If I put a 9 here, that would be a... If I put on the 6th row, if I put a 7 here, that would be a... 67. Okay, I can't fool you guys. So your job now, please get with a partner, because there's a lot of data here, and take your chart you're first going to have to probably put them in order. So it's going to be a pain, but we don't really care about the countries anymore. You're going to just put the numbers in order, and then you're going to build this up, okay? And I think what I'm going to do, I'm going to pause the recording because nobody wants to stare at this page for the next 10 minutes. So we'll pause. Just checking if I can add to this recording. Okay, I don't think, did anybody get it all done?
No.
Anybody close?
Yes, sir.
Oh, you did finish.
Yes. 5 more minutes.
Let me see a picture of it.
See from here, sir.
Okay, let me take a picture of it here. And maybe I can put it in our, it probably did stop. So let me add this picture. Picture.
Do you know how to use the calculator for like the graphs? Can you help me? Cause like I got so messed up. Like
Oh, it did. Okay, so I will done. Put it right here. Look at this. I'll put it right next to it. So let's all take a look at this because we only got like 4 minutes left. And I'll make it big first here. It looks like, that was nice. A lot of ones, a lot of twos, a lot of threes. Is this picture skewed left or skewed right? So you got to say, is the small tail going to the bigger numbers or the smaller numbers? The bigger numbers. Because look at here. A lot of doesn't do the, oh. You've got these up here. If you turn it around like this, look at that. Turn it like that, you'll see that it's skewed to the right. Okay? If I put the axis at the bottom here so that I can see it, it's skewed to the right. All right? And the median would be really hard to figure out. So we're going to stop here, but your assignment, yeah, is in that little packet that had 4 problems, I think. Number 1 and number 2. I'm going to ask you to make computerized histograms. The calculator. You're supposed to be able to choose what you want, a stem and leaf or a histogram. But you can't do a stem and leaf in the calculator. You can only do the histogram in the calculator. So I'm going to want to see you do those 2 problems.
1 and 2.
1 and 2. All right?
And then what about the?
So we're going to call it, so say goodbye in case anybody sees this, if I post this or not.
Wait, follow me on Twitter.
Bye.